Welcome all. My name is JJ Sharma. I'm the TVM and FinOps practice lead for KPMG Australia. With us today is Andrew Midgley, Principal Product Marketing Manager for IBM Cloudability.
Thanks, JJ. So one thing I can tell you is that certainly my manager has never given me $500,000 to go on training, that's for sure. But yeah, it's awesome to be back at reInvent. Over 10 years for me working on cloudability, it's been an amazing ride. What I would say is that this AI wave that we're going through right now, for me personally, has been very invigorating. To me, it feels quite momentous, very similar to the way it felt in the early days of public cloud. So moving forward, it's very exciting working with our customers with just how transformational this technology is. So yeah, it's great to be with you today. So let's just quickly start with the scale of what's happening right now in AI. Gartner is predicting that global spending on generative AI will hit $664 billion this year. That's up more than 75% from 2024. It's massive growth. Pretty much every company is investing in AI somewhere right now. But here's the reality check. Less than 30% of AI leaders say that their CEOs are happy with the return they're getting on that spending. So there's a bit of a problem here. So while everyone's racing to build and deploy AI, most organizations are still figuring out how to make it financially worthwhile. And that's really what this session is about. Bringing some financial discipline to AI so that all the innovation that we're investing in actually delivers on its goals. So my goal for you today is that you can leave this session with a clear view of the key trends shaping GenAI, the options and cost considerations when running these workloads on AWS, and how FinOps can turn this spend into measurable business value. So what will we actually cover today? JJ will start with a quick overview of FinOps and what we're hearing from the FinOps community. Hopefully that's a few of you here. Then we'll take a strategic look at AI trends. What's happening in the broader marketplace from technology providers, and how the GenAI operating model is evolving from the point of view of consumers. From there, we'll review the main deployment modes for GenAI, from SaaS APIs through to fully self-managed infrastructure, and how those choices impact both flexibility and your cost control. We'll follow that with a deep dive into AWS services and pricing, so you can see how costs break down across the build, train, and run phases. After that, we'll talk about key FinOps practices that you can apply right now to get better visibility, better predictability, and better efficiency for your AI spend. And finally, we'll wrap up with unit economics. How to measure success with AI, not by total spend, but by cost per transaction, per user, whatever matters for you, so that we can tie investment directly back to value. And for a quick introduction to FinOps.
I think a learned audience would know a lot about FinOps, but I often meet new colleagues at KPMG who work in different technology areas. And the way I describe it is, it's a collective brains trust of about 65,000 practicing professionals. And what that gives us collectively, that brains trust, is tooling, processes, best practices that we call as the discipline of cloud FinOps. And it does two very important things for us. It helps us have the conversation in the metrics that business, finance, and technology understand for themselves and with FinOps for each other. And the second thing that it does for us is it helps us to align our initiatives and get the best out of our cloud investments in terms of maximizing its business value. Want to talk about the foundation?
Next slide. Oh, the foundation? Yeah. Yeah, I guess, sorry. Yeah, so the FinOps Foundation, as you said, I think about 65,000 people in that community.
Yep.
So I'm going to guess a few of you are amongst that group. Yeah, so it's I mean, I encourage everyone to get involved, just to Google the FinOps Foundation. Yeah, Their website has so many good practices and recommendations and videos and information about vendors like us. But yeah, that's sort of the foundation has grown up to sort of solve these problems around cloud cost optimization, cloud cost management, making sure that we're all maximizing the value of these investments. And there's obviously a massive push within the FinOps Foundation around AI as well. White papers around AI, there's a lot of thought leadership there to go to.
Great. And one of the things that the foundation does is to take a pulse of the community itself. And these are the results from the latest survey of 2025. Mitch, does it surprise you to see where AI and ML spend is?
Yeah, well, it sort of does. So I'll just backtrack a little bit. So obviously this survey goes out every year. So we're getting that feedback from the community about what's important to you, what are your priorities, what are your challenges, all kinds of information. Is Kubernetes an area of concern, whatever. So I believe there's about 1,000 practitioners actually respond to this every year. Yep. So I might actually just pause for a second. Has anyone here actually contributed to the State of FinOps report?
Great.
Yeah, got a few. So recommend everyone go and check it out. So data.finops.org is the website. Every year it's run. Obviously 1,000 practitioners, you're getting a lot of information about what's important to the community. So yeah, I was surprised because looking back to the prior 12 months, the FinOps community said this was amongst AI and ML was amongst the absolute lowest priorities. And I was quite surprised by that. Looking forward to the next 12 months, which is what the slide is here, you can see that it's actually now bumped up 4 places to sort of the middle of the pack priority. So I was surprised, but I think, yeah, we have some ideas around that.
I was surprised, but in a very different manner. I was mostly surprised to see how everything that's shot up has like just bursted up 4 or 5 spots. That's very unusual. And now governance is a higher priority than waste reduction. Quickly followed by the idea of not just looking at cloud, but beyond cloud, and getting into unit economics, and doing so by enabled automation. So we're talking about an altogether different scale of prioritization for the FinOps practitioners. And when I sort of look at this more as a forest instead of the individual trees, then I think there's a clear recognition here that we're now expected not just to be tactically optimizing as practitioners all the time, but got to take a more strategic view of things and align our outcomes to that business value.
Yeah. Perfect.
So just so we can continue speaking this candidly with you, just want to make sure that we get the gist of it, that this is a purely educational presentation, and we're not here to endorse any products or services. And may I request you all to keep us honest here. So if you hear anything that sounds even remotely like endorsement, I urge you to stop us, and we fix that. All right? Thank you. So we talked a couple of times about taking a strategic view. How do you do that? How do you take a strategic view? So let's talk about in the context of GenAI. And a good starting point is to ask some simple questions about any technology to get started with that strategic outlook. I usually think about why. Why are we going to be using it? What? What is the economic environment in which we're going to be using it? And how? How are we going to adopt it? How much of it are we going to be using? So if you ask the same 3 questions of GenAI, my first impression with GenAI was ChatGPT coming out about November 2022. And just the language intelligence of the whole thing. You could do emails, summaries, blogs, content creation in seconds instead of hours, Excel formulas, code reviews, code rewrites. Such wide range of application towards knowledge work. So the why was very quickly answered right from the onset in terms of its very compelling value proposition of why would we look to use it. So this almost near vertical graph of GenAI Doesn't surprise me. In fact, as Midge said, you'd be hard-pressed to find an organization that's operating in cloud today and is not doing something with GenAI. Would you all agree? Yeah? So let's talk about the what, the economic environment in which this is likely to operate. The prices at which this technology is being offered are plummeting. Look at the graph in purple for ChatGPT-4. Every step down is on a logarithmic scale. So within a period of 18 months, it's come down 100 times. 100 times. Mitch, microeconomics 101, when prices go down, what happens to demand?
I think it normally goes up, right?
Yes, right. Demand goes up, price elasticity of demand, right? So there's this growing expectation. Already there's so much demand. Almost every CEO who saw that investment is willing to put the money out there. And that's kind of where we are hearing all the supply side being shored up by these billions and trillions of dollars of deal to build these big data centers and whatnot to meet that demand. Some of these deals are so big that $1 billion sometimes sounds like $1 million. And add to that the idea of research being done by firms like DeepSeek using model distillation and whatever techniques and investments happening all over the world, not just in US and China, we can say that the economic environment suggests that this technology is very likely to be available to us abundantly, reliably, economically, at a global scale.
Couple of thoughts about that, JJ. So, first thought is actually just go back for one second. So the first thought is that this is definitely pushing towards commoditary territory. These Gen AI technology is being commoditized.
Yep.
A little bit like electricity, which I think we'll talk about in a moment. The other thing that comes to mind, just seeing these charts of these costs just dropping like precipitously, is Moore's law being turbocharged. So we're sort of used to Moore's law, where the cost of computing power is going to be dropping by half about every 18 months to 2 years. That's been the case for decades. And just to see these charts go like this is incredible. And so we're sort of seeing, instead of it being 18 months to 2 years, we're seeing it be more like 2 months to 3 months. And the compounding effect of that is just huge. And so that's why we're seeing this sort of the cost really dropping,
Absolutely.
This commoditization that you're touching on heading. And so, it reminds me of a commoditization of something like electricity.
Great. I think you're in some very elite company when you compare this to electricity. Industry stalwarts like Andrew Ng have predicted exactly that, is that this would be as transformative as electricity was. But what that comparison also does is it gives us a roadmap to answer the third part, the how are we going to adopt to this, right? Leading researchers in this area, like Dr. Ajay Agarwal and others, have published a lot of good research that shows parallels between electricity and AI. And they posit that electricity transformed the world in 3 stages. Or you could consider that at 3 different scales. The first, as a point solution, was quite simple, replacing steam. You took the steam engine out, you put an electrical generator in, everything else about your factory remains exactly the same. You produce the same output. You just now have a cheaper, cleaner fuel, and you've unlocked some value. As knowledge of using electricity improved, tooling started to improve as well. Lathes, mills, drills started having these small electrical motors. And so now you could fractionalize your manufacturing by turning those individual machines on and off. And that meant you are now paying for power only when you were using it. And that unlocked a little more value. And then the architects started to look at the unique properties of electricity and realized that we could transfer power from one corner of the factory to another using these very small cables. And that gave them the design flexibility to start putting machines in the order of the completion of the process rather than their power intensiveness and consumptiveness. And that gave us the single greatest productivity invention of the 20th century, the assembly line. It optimized the whole factory for the flow. If we take that analogy towards AI and see some parallels, we're already seeing a lot of use cases that talk about task substitution. Clearly, this thing is far better, cheaper, and faster at some of the things than most humans. And we're seeing all kinds of content creation, first drafts, business writing, great examples of where we're leveraging this task substitution type of value creation with this technology. Take it a step further, and we're also looking at areas. Thanks. And we're also looking at areas where we're augmenting human and AI, with the idea being that the human expert focuses more on high-value activities, and AI does the legwork. Good examples would be in medicine. Diagnostics can be predicted much better with AI technology now, and the doctor can focus on treatment considerations individualized to each patient. And thereby, you get a better output and outcome for the patients. And I know this conference has been a lot about agentic and what agents can do by orchestrating things between themselves, et cetera, but in the long run, what may be possible is possibly anybody's guess at this point in time. But one thread that's clear is that all of that is going to evolve rapidly and in ways that may not be very directly imaginable today, just like it was quite unimaginable to consider that a whole city would be powered by one power station. Electricity made that possible. But taking this to FinOps, what are the considerations for FinOps here? Right? From a FinOps standpoint, what we need to think about is, I gave the example at 3 different scales, point, application, and system, and your cost and governance considerations move very non-linearly at these 3 different scales. And so when FinOps practices think about value versus cost, that's the key thing that they need to consider is what are the cost drivers and how would they scale as the usage scales, right? So let's look at that next. Mitch, you drive a car?
Sorry?
You drive a car?
I do drive a car.
Great. It's got some running expenses, I suppose?
It certainly does.
What would you say is the topmost running expense from your perspective? Or
I would say it's petrol.
petrol?
Yep.
Great. What would be some of your other running expenses that come to mind?
Insurance.
Yep.
Registration.
Yep.
Tires.
Yep.
Servicing.
Yep.
I think that's about it.
Yep. Okay, great. Wonderful. How about parking?
Occasionally.
Occasionally?
Yes.
How about infringement?
Not for a while. Not for a while.
That's good.
Yeah.
That's good. Why I was just teasing that out is, as you see, when we think about the running cost, we usually think about the most consumptive element of it. But when you look at the scale of things, there are so many other contributing factors. And if you consider just that example of driving car, your fuel cost may be what, like $200 a month, but once you add all the rest of it up, it's a sizable amount. Yeah? So let's look at what the cost drivers for GenAI are, and just keep that sort of perspective of it. So what the industry calls as inference is basically a user, in simple terms, using an application, sends a prompt, gets a response back, you meter that, and you get some kind of token consumption, and based on the price of that token, you get some kind of token cost, right? But that inference is more like the tip of the iceberg. What's underneath that is to make that happen, you would still have all these other costs in your cloud environments across production, staging, and dev. And if you're building and training your own models, there'll be even more cost to get that up and running in cloud. But that's not all. How about security, design, observability, support and maintenance? How about product management? How do you get your users to use it? Enablement. All of these are very genuine elements of getting to value. And many of them may respond very differently as your solutions scale. A few slides back, we saw how the inference cost is coming down because of the model unit pricing coming down that much. Well, what do you think is happening to some of these other elements? Do you reckon any of them are going up instead of coming down? How about the talent required to do these activities? Right? So there's a lot to think about, like where are our biggest cost risks and governance controls would need to be to stay on top of this thing.
Yeah.
Right? So keep these elements in mind as I talk to you about one of our success stories with GenAI. So as ChatGPT, OpenAI came out towards end of 2022, early 2023, many member firm countries started to explore this wonderful new technology that provided so much potential to innovate. And they kept going at it for about a year. And about March 2024, they started comparing some of their notes. And they found that eventually they had built something very similar, because the underlying use case was quite the same. How do we get our workforce to be more productive? How do we get our consulting teams to be more productive in their engagements? And typically evolved around those three examples that I showed: chat, search, and the third one being chat, search, and chat, search, and I'll just go back and see what the third one is: translation. Thank you. But they also realized that they were facing some very common challenges around deployment, support and maintenance, release maintenance, enablement, adoption. Our surveys indicated that many of our own people, as well as the clients, were a little skeptical of using AI-generated outputs. But the key question was, should we continue down the individual path track, investing time, effort, and money in our silos? Or are there economies of scale and scope to be unlocked? And the answer to that was the genesis of what we call the KPMG Workbench, envisaged as a globally available platform that would enable many, many applications to leverage GenAI offerings in a provider-agnostic manner. And the role that FinOps had to play in such a global scale is to be highly strategic in terms of engaging with the stakeholders and understand that once we go to this global level of scale, how are we going to invest in this? How are we going to fund this? What are the initiatives that are being taken to onboard countries, to bring on developers, and working with these teams to understand what timeline this will scale at, and how would we then price it? We often think of chargeback as a mechanism wherein we are looking at whatever it's costing us and then finding a fair and reasonable way of distributing that onto the users so that it's cost neutral to offer for technology teams, and also so that the user can see what it's costing and they can make a judgment on the value. But when you take a strategic view, you have to consider you don't come up with a chargeback program where you're asking the first passenger to buy the bus. This thing will scale at a certain time to a certain level, and then only those unit costs will make sense to apply. So roll this forward to where we are today. And today, KPMG Workbench is available across 100+ member firm countries. It's onboarded over 100,000 users, hundreds of developers, 30+ applications. We are about to go live with 12 modular agents, hundreds more in development, enabling multiple teams across multiple countries in a globally secure, safe, data-governed, data-sovereign environments to leverage this great technology and improve their engagements, both internally as well as with the clients. So that's the scale of what's possible. And we have a long way to go. We've just started. This has just been a journey of about 18 months. But as there's so much more to do, what I would say is, as Mitch talks to you about some of the deployment options next, please consider this idea of what's critical to your organizations as you leverage this at the scale that it's potentially possible to leverage at.
Awesome. So strap yourself in. We're going to go through some implementation details, the trade-offs that you're going to look to make, and then we're going to dive into some FinOps practices that we will apply here. So, so walking through the three main ways organizations deploy generative AI today. So SaaS, PaaS, and IaaS. These are undoubtedly familiar cloud patterns, but the trade-offs for GenAI are extremely important. So we'll go through those. So starting on the left with SaaS APIs, these include providers like OpenAI, Anthropic, and Cohere. You get instant access to powerful foundation models with almost no setup. You're typically charged per token or per API call, so costs scale very cleanly with usage. A major advantage is the ecosystem of out-of-the-box tools these providers offer. So things like built-in chat interfaces, coding assistants, productivity apps, this all comes with it. But so if sharing data with a third party isn't a concern and you don't need deep customization, this SaaS APIs is a very compelling option. And I know, talking from our own head of AI on the cloudability side, there are many scenarios we would love to take this approach, because it just comes with all of these sort of bells and whistles sort of for free in a sense. But if sharing your data with a third party is an issue, or if you need to do a lot of customization, it's just not going to be possible. Yep. In the middle, we have PaaS. So PaaS for AWS, that comprises two services, and we're going to talk a lot about those in a moment. So they are SageMaker, Amazon SageMaker, and Amazon Bedrock. This gives you more flexibility compared to SaaS, while still offloading a lot of the operational burden. You can run pre-trained models, you can fine-tune them, or you can even build your own. The good news is that AWS takes care of the scaling, the patching, and availability. You are charged based on usage, and crucially, you retain control of your data boundaries. And a really key point here is that there are quite a few very popular GenAI models, for example, like Claude 4, Amazon Titan. The only way you can actually run these models in AWS is to use Bedrock. It's the only option you have available to you. Finally, IaaS on the right-hand side. This is a self-hosted path, and this centers around EC2 or EKS, where typically you're going to run an open source model or run your own custom models. You have full control over the architecture, the scaling, optimization, the data handling. But of course, with that control comes all the operational complexity. Here, you're primarily paying for the provisioned EC2 instances, which are usually backed by GPUs. What you have is maximum flexibility, but it also requires the most expertise from your side. So in summary, each deployment mode reflects a trade-off between control, customization, and operational complexity. So now that we've looked at the three different ways that GenAI can be deployed, I want to ground that in what we're seeing from our own customers on AWS. So let's just start on the left. This chart shows the EC2 instance spend breakdown across our customer base. What's interesting here is that about 15% of all EC2 spend is now on GPU-backed instances. We can't say that's entirely AI. Some of it will be for HPC or graphics workloads. But a large portion of this growth is directly tied to GenAI adoption. And for me, that's a really striking number, 15%. GPU usage at this scale didn't exist a couple of years ago. And it just shows how quickly GenAI workloads have become a meaningful slice of our overall AWS and overall cloud spend. Now on the right, we isolate spend that we know is associated with AI and compare GPU-backed instances to the managed services. What we see is the majority of spend today is actually still on the self-hosted GPU infrastructure. Bedrock and SageMaker represent a smaller but steadily growing share. And this really does make sense. Many organizations started their GenAI journey experimenting, doing that with open source models or custom deployments that they could actually go ahead and tune. But we now expect to see a shift very strongly towards the managed services because the models that back those are evolving from the vendors. As organizations mature, they really care about time to value, and that's really going to give them much better time to value. So just a little bit of a summary here of the managed services. So in terms of managed services, a quick distinction. Amazon Bedrock is the serverless way to run existing models. It's primarily used for foundation models, but it also supports bringing your own model through custom model imports. Amazon SageMaker, this is the end-to-end machine learning platform on AWS. It covers everything from data preparation to training, fine-tuning, deployment, and production inference. Yeah, so just handy visualization to see where these two services fit together. So I'm going to dive into each of these services. So starting with Bedrock. As we just saw, Bedrock is serverless, so there's no need to provision instances, and you get really easy access to really powerful foundation models. The first workload category that you see there is the one that everyone knows best: reasoning and text generation. This is where models like Claude 4 or Llama 3 handle tasks like answering questions, summarizing information, generating content, or acting as interactive agents. So things you're probably quite familiar with. Pricing here is based on tokens, and these are just really small chunks of text. The general sort of way people frame this at about 3/4 of a word is a token. If you Google more about it, you'll find out how that kind of breaks down. But yeah, so you're paying for tokens, you're paying for what's sent into the model, and you're also paying for what is sent out of the model. So yeah, your cloud spend really directly tracks with actual usage. Another major category is RAG, Retrieval Augmented Generation. So RAG is all about giving the model the extra context it needs to answer questions accurately. Instead of relying only what the model was trained on, RAG lets you bring in documents, knowledge bases, or business-specific information at query time. This helps reduce hallucination and ensures the model's responses are grounded in real, trusted sources. It is one of the most common patterns because it's often the fastest and most cost-effective way to make a model truly useful to your business. So talking from our perspective on cloudability, RAG's really important to what we do. But of course, there is these costs that are associated with it. All right, so switching over to SageMaker, AWS's end-to-end machine learning platform. Let me walk you through the typical cost areas you're going to encounter. So starting at the top, the building phase usually runs on lightweight instances like MLT3s or MLM5s. This is where teams prep data, explore notebooks, and prototype ideas. It always is pretty much the lowest cost phase from an infrastructure standpoint. It's not particularly expensive, even though it's where a lot of the actual hands-on development process happens. Mm-hmm. Next is training, which is where SageMaker really shines. So this is where you scale out on GPU clusters, typically backed by P4 or P5 instances, for deep learning, fine-tuning foundation models, or running large distributed training jobs. It's also the most expensive in most ML pipelines, the $500,000 that you said before, JJ. So visibility and optimization is really, really important here. Finally, we get to the third row, which is inference, which is all about serving those models back to consumers in production. SageMaker gives you a few options here that you can choose from. So you can use regular GPU-backed instances, or you can run on Inferentia 2, I hope I pronounced that correctly, which is custom silicon from AWS, purpose-built for high-throughput, low-cost inference. And if you want to avoid managing instances altogether, SageMaker actually does have a serverless option as well. So yeah, generally speaking, I'm hoping that the pricing structure here should feel fairly familiar, given how closely it actually is tied to EC2. Now let's take a look at EC2 itself. So this is obviously the fully self-managed option. As we mentioned earlier, it's still the backbone for a lot of GenAI workloads because it gives teams complete flexibility over the environment. And at a very large scale, what will tend to happen is this will actually be the cheapest option as well. So just like with SageMaker, the workflows break down into the same three phases. So you've got our building again, so using lightweight CPU instances like T3s or your M5s to set up a dev environments, run your notebooks, and iterate quickly. Second, training, again, very similar, typically on the P instance families for large-scale training and fine-tuning where GPU performance really matters. And then the final one here is inference, traditionally on the G instances with the obviously NVIDIA GPUs, but increasingly these are shifting over to Inferentia 2, which is the chips from AWS, purpose-built for this. So conceptually, this really does mirror SageMaker, even down to the same instance families. But the point here is that you're actually really in charge of the entire stack. It's a little bit cheaper.
It's way too many options to consider. And what you got to just think about is what is your organization's capability of handling. At the same time, contrast that with what is the purpose to which you're working, and do you really need that level of flexibility? Because this can really get very intensive for your human resource team, your talented people, to work out all those details. So if you're just doing some minor experimenting type of work, you may be able to use just the basic SaaS offering and test it out first. But yes, if you truly need to scale to a solution to what it needs to be, and you need all the flexibility, then there's all those options certainly available.
Absolutely. All right, so as a FinOps person, this is the more fun part for me. Our FinOps practices. So the diagram you had up earlier, we had the three phases: inform, optimize, operate. Yep. So of course we're going to start with inform. That's where it all begins. Mm-hmm. Now, I often say to people, if you're good at cost allocation, there's a good chance you'll be good at FinOps. Good chance. If you're bad at cost allocation, you will be bad at FinOps. So it really is the foundation to everything. So of course it's the foundation to everything AI as well in terms of FinOps. So the first place to start are areas where we can directly map these costs back to teams. So some of this AI infrastructure will be entirely owned by one team or one business unit, one group, etc. So we want to have strategies that we can fully allocate those costs back to that team, business unit, whatever it might be. And so the two main things that we use in AWS, regardless of really what service it is going to be accounts and tags. And you can see some of the details about those constructs on the slide. So accounts are the most foolproof way. You know, you're provisioning resources in an account, so we can use that directly to map costs back in some cases. In other cases, you might have a shared account where resources are existing together, in which case tags become the most useful way of doing the allocation. So the good news is that all of these services that we just went through, they do all support tags. SageMaker, EC2, Bedrock, they all support tags. So we need to be working with our engineers to make sure that we're using the right team tag, the right business unit tag, department tag, so on and so forth. And then at the end of it, we want to try and use ideally, like a mapping engine, because undoubtedly you're going to have a mixture of rules. Sometimes you use a tag, sometimes you use a count, use other things as well. We'll try and use a mapping engine to officially sort of like assign those costs back to the business and try and automate a chargeback. So for this scenario, ideally, we have all of our team-owned AI costs. We're using these strategies that are automatically getting charged back. So that's the first thing about allocation. That isn't always the case. So just like you have databases that might be shared or APIs that might be shared, for sure, you're going to have AI infrastructure that is shared. And so you're going to need to find a way to allocate that as cost back to the consumers. And again, we're going to use a very similar strategy that we would with a database or an API. And we're going to try and use consumption data, which we would normally refer to as telemetry data. So with a database, for example, if we've got 5 different teams using the one database, we might use something like database transactions to split those costs up. So if you have 50% of the database transactions, you get 50% of the cost. So how are we going to do that with AI, with GenAI? So the most obvious telemetry data is going to be something like tokens. So if we have our 5 consumers and we can track how many tokens that each of those consumers is using, we can now split those costs up and allocate them back as needed. Yeah, but at the end of the day, the net result of both of these types of cost allocation is that all that costs are allocated back accurately. We're now able to start holding our teams accountable. So yeah, do you have any sort of experiences that are worth sharing on this topic?
Well, we've always found that nobody likes receiving costs. I would say it's not very different in the context of AI cost versus if you're doing chargeback in other areas of the cloud. One common thread that comes out is if you're charging somebody, they should have some kind of a lever about their usage so they can work on it and use it more or less of. The worst outcome from their perspective would be that they are getting charged for something, but they have little to no control about it. So when you choose that telemetry, as you were talking about, see that there is some kind of a lever, some kind of a mechanism that user behavior ties it to that telemetry, ties it to their portioned cost. So share,
yes,
but with a little care.
Yes, make sure it's accurate.
Yes.
Awesome. All right, so now that we've got our first phase, we've got our foundations there, we're working towards being successful at FinOps, we can now start optimizing. And there's sort of 2 parts of optimizing. One is optimizing usage, one's optimizing rates. We'll talk about rates in a second. So optimizing usage is really, really specific to the type of resources that you're working with. So with AI, GenAI, you do have some quite specific things that you need to think about. So I'll just go through these levers that you have here. So the first one is to choose the right foundation models for the job. No matter what mode you're using, the 3 modes we went through earlier, this is something you're going to have to do. And if you choose the wrong model that's inefficient for what you're doing, like you're going to be inefficient. So it's the commonality there. So yeah, look at the model. You'll see there's light models or mini models or domain-specific models. They're going to be cheaper, and often they'll be more performant as well. So as a FinOps practitioner, there's only so much we can do here. But as our head of AI, when I asked him, I said, should the FinOps practitioners, be talking to the engineering people, questioning these kind of things? Should we be, facilitating these conversations as FinOps people? His answer is yes. We need to do that. The second one here is probably one that's more familiar: right-sizing instances and EKS. If these things are over-provisioned, we see cases where the GPUs aren't even used. Just make sure you're turning these things off, getting the right size. Caching, just like we can cache database requests, we can cache cache GenAI interactions. So if there's prompts that are coming in that are kind of consistent, we can cache those. And finally, batching. And there's actually one that confused me a little bit initially. I was like, well, how would batching work? Because normally when you batch something, you batch it up for a while, then you run it overnight. That's not how this works. This is kind of like micro batching, where it's happening really, really quickly in real time, and it's just trying to take load off the GPUs by grouping requests together. So yeah, just some quick things there for optimizing usage. Optimizing rates. Again, so this is the other side of optimizing. You commit to ongoing levels of usage. Amazon gives you significant discounting as a part of that. It's great because you don't really need much engineering effort. What we just saw a moment ago, you do. With this, you don't. I think most people will be familiar with the EC2 side of this. The savings plans and reserved instances, everything is really moving towards reserved instances. We saw an announcement yesterday from AWS. Now they're available for RDS. Savings plans are available for that. So everything is really moving towards that. And yeah, savings plans are great because you get they are more flexible, they're easier to manage, and you do end up with a higher savings rate in a sense that they sort of gravitate to the highest saving resources. In terms of SageMaker, they have savings plans. So I would say they're most similar to compute savings plans for EC2. And they're similar in a sense that they will go across regions, they'll go across instance families. So if you want to think about SageMaker savings plans, think of compute savings plans. They work in a very similar way. One thing that did kind of confuse me in the past was I wondered whether compute savings plans would apply to SageMaker. They don't, is the answer to that one. Bedrock is the unique one here. So in terms of making commitment there, it's called provision throughput, but it's actually primarily about performance. You're doing it to try and guarantee that throughput, and you do get a discount with it as well. Those discounts are not published, so it's hard to exactly know what they are, but we hear they're about 20 to 40%. But the point is, with Bedrock, if you are going to be doing these commitments like this, you need to have a really high base load to make that worthwhile. All right, so getting to the last phase of, so we've done inform, we've done optimize, and now we're going to do operate.
Great, thank you.
We're going to finish up in a minute.
Yep. This is all about tying back to the business value in the operate phase, right? At KPMG, we have maintained a repository in SharePoint around all our AI use cases. Anything that anybody thought they could do something with UI that will generate value for the business, we try and get an entry into that repository. And last I checked, there were like 1,600 sort of rows of data in that. I'm sure some of you would have something similar in nature, right? But when you look at categorizing those 1,600 into the scale aspect of it, they kind of boil down to those three areas. So let's look at that unit economics in that same fashion of those three different scales. First is experimenting. Your teams are looking to do something with GenAI to test out that is this thing predicting with reliable accuracy that I can build some automation on top of it and create an offering that would be worthwhile, right? I'm sure many of you have this use case or use cases similar to that. And what's key here is to look at the unit economics lens in the context of what is the cost per such experiment, right? What is the expected learning that we're looking to get and what is that costing? And that's most relevant to the business. So we can focus on token cost or GPU hour cost, and for short-lived workloads, that may be just enough, right? Use some sort of SaaS or PaaS offering and get to that. And examples would be you could look at cost per 1,000 or million tokens or cost per fine-tuning run. Talked about the second idea or category would be that big productivity boosting, augmenting type of use case. And here you're looking to obviously boost the team performance or individual's performance, and at the same time you want to have a control on the costs, right? And the unit economics lens then needs to shift to what is the cost per that assistance that AI is able to provide, or per that user interaction. If it's support triaging or summarizing of a document, what is that individual activity task costing us by leveraging AI? And have a baseline from non-AI to compare it to so that you get some sense of value versus the cost. That's your productivity uplift. The third case is where we are looking to build something that previously we just couldn't do without AI. So it's like something that will differentiate our offering, something completely net new as a new feature into a product or a service. And I'm sure many of you are building such wonderful things, right? And here you're looking at that strategic advantage. So the unit of that advantage would be something tied either to some kind of a revenue generating outcome or something where the AI feature has very directly improved the business value. And a couple of examples there are, if you're looking at it in terms of sales or marketing leads that are being closed, or any kind of AI-driven fraud detection type of services that basically very directly impacted your top or bottom line.
Awesome. Oh, we're just about to finish up here. We've used our full allotment of time nearly. All right, so some key resources to take back with you here, but some thoughts for you as you go back next week to your office, back to work. So what are some things that you can look to action? Well, if you're early as a FinOps practitioner on this AI journey, maybe start at a high level. Just try and capture what is your total AI spend across AWS, across other vendors, across SaaS, whatever it might be. Just try and capture that total cost. Try and report that back every week. Maybe that's something you could look to do. If you're further along on that journey, maybe you've started allocating costs, but you haven't got your shared costs done yet. Make sure you bring in that telemetry data. Make sure that those shared AI infrastructure costs can be allocated back. Maybe you're even past that. Maybe you're doing really well, and it comes down to unit economics. Be clear with your teams. What is that unit metric that you're tracking to? Do you have a unit metric, and work towards that? So that's what we have for you today. Thank you for joining us. We appreciate it. I think we have a few minutes for questions.
Yes, we're happy to take questions. Thank you.